All right, more on Intro to Statistics, Math 5130. Key concept, what we're going to get into in this video, it's going to be a very brief video. We're going to look at things called histograms. And what I want you to know right now about a histogram is it's one of two ways that we'll investigate to analyze single or univariate quantitative data. So if we have a single variable and it's quantitative, and that would fall into that ratio or interval definition that we talked about in a previous video, then a histogram is one choice for appropriately visualizing our data. And it actually turns out that we can get some pretty interesting conclusions from a histogram. So histogram, what I want to know again, it's a graph. We're not going to get into drawing bars of equal width and all that. If we want a histogram, we're going to plug our data into technology, and I'm going to show you how to, create one. But the most important thing with the histogram is once we get it created, what conclusions can we draw about our sample data based solely on the histogram? Now, another graph that we're going to use for quantitative data will be a box plot, but that is in a different video. So important uses of a histogram. To me, all this other stuff is correct. Bullets 2, 3, and 4, those are true statements. I don't necessarily like bullet 3 as much. I think when I want to identify outliers, I'm going to use a box plot. Again, more about that later. But for me, Dr. Darbro, your professor, right, creating these videos, I think the most important use of a histogram is to determine the shape of the distribution. And the shape of a distribution is extremely important because it gives us an indication of the relationship between the mean and the median, and it gives us an important indication of the type of variability that we need to report. And again, just be patient with me, and I'll create all this as we go. So common shapes of distribution. And I will tell you that top left, the green, drives me insane. That is not a normal distribution. A normal distribution is a theoretical distribution that comes from a population, that describes a population. When we create a histogram, we are dealing with sample data. Now, this is a good time to pump the brakes and let's think from 30,000 feet, what role in the grander scheme of things does a histogram play? Well, again, the purpose of statistics is to take a sample and make a statement about a population. And now, if our population is 10 doctors, then heck, just get your 10 doctors, and you don't need any inferential. You don't need p-values. You don't need confidence intervals, all this stuff, fancy stuff that I'm going to teach you later on. But if you're trying to draw from, 4 or 5 healthcare facilities and collecting every single person, doctor, nurse, whatever it is in your population isn't possible, then we draw a sample. The first step that we do in reporting the data and hopefully maybe even getting to publication is to describe our sample data. And then we use these fancy statistical techniques to generalize to the population later. ANOVA, regression, t-test, all these things that I'm going to teach you, chi-square, all these things I'm going to teach you later. But the purpose of a histogram is to describe the distribution shape of our sample data. So stop this stuff. It's just wrong. Up here on the left, that's not a normal distribution. That is a bell-shaped distribution from our sample data. Normal distribution, again, I hate to be redundant, but it's important that people make these mistakes all the time, describes our population. And typically, we don't even know our population. That's the goal of the study, is to try to make that statement. Top right in the red, we have a uniform distribution. That's where all the frequencies in each Each level, and the levels here were 0 to 9, are about the same. The bottom right, the blue, that's a positively skewed distribution, or skewed to the right. And the brown at the bottom is skewed to the left, or a negatively skewed distribution. Now, the characteristics of a positively skewed distribution, bottom left, blue, is the mean will be greater than the median, and the characteristic is you'll have a tail out to the right, going toward the more positive numbers. Because what happens if we go left? Well, left, we go down to 0, and I'll keep going left, we're going toward the negative numbers, right? So that's why we say skewed to the right, or positively skewed, because the tail is going toward the positive side. Compare that and contrast that to the brown distribution skewed to the left. Our tail goes to the left toward the negative numbers. You're like, well, there are no negative numbers. Well, there are negative numbers. If we start at the 70 and go down to the 60 and then the 50 and the 40 and 30 and 20 and 10 and 0, and then what comes next? Negative 10, negative 20, negative 30. So the negative numbers are pointing over to the left on the x-axis. So tattooed to the brain. Bell-shaped and symmetric is something we hope to see in many statistical, using many statistical procedures that we'll implement. Because what we'll find out is that once we get fancy and get into the more sophisticated stuff, we'll find that we get into statistical assumptions. And sometimes assumptions are that our population is normally distributed. Well, we can't get our population, it's unknown. So we draw this sample, and if our sample data is bell-shaped and symmetric, then it's more likely than not that the population we drew this from is normally distributed. Now, that's something I would encourage you, and that's one of the great things about having these instructional videos on taped, is that you can replay things. If that didn't make sense, I think you should replay about the last 15 to 20 seconds and until it does make sense. And if not, email me and we'll either try to discuss it via email or a phone call, or we'll jump on Blackboard Collaborate or whatever. We'll get this figured out. But I look at this green histogram in front of me. That histogram looks bell-shaped and symmetric to me, within reason. And it's reasonable for me to assume that this distribution of numbers, arm circumference, came from a population that is normally distributed. Now, when I look at this is a positively skewed distribution. If I get something like that, I'm not as convinced that that distribution came from a population that is normally distributed. But we'll get into these things called test of Shapiro, all these, kind of, again, fancy tests where we can create a test statistic and a p-value to make these determinations. But right now, eyeballing, I look at this histogram. It looks skewed to the right, positively skewed to me. So the likelihood that this sample data came from a population that's positively or that's normally distributed isn't likely. Same thing with this. This is skewed to the left, negatively skewed, and so on. Well, that's it. I thought there was another slide, but there wasn't. Take care.